Hey everyone, welcome to Code Harmony. Today we'll be solving LeetCode from ID 2311. Longest binary subsequence less than or equal to k. It is a very interesting question, and here we'll be using two approaches. One with recursion and second one with greedy, which is the highly optimized approach. And this question has been asked in Google recently. And this question is going to teach you a lot of good concepts. Let's have a look on the problem statement. You are given a binary string s and a positive integer k. Return the length of longest subsequence of s that makes up a binary number less than or equal to k. So k is an integer given to us, and we have to find out the longest subsequence from this binary string which is making number less than equal to k. Some notes: subsequence can contain leading zeros. Okay. So if we are picking up items, we just have to pick it randomly. If it is having leading zeros, then it is perfectly fine. It is going to contribute to the answer. The empty string is considered to be equal to 0. A subsequence is a string that is derived by another string by deleting some or no characters without changing the order. So this is just the definition of subsequence. So what is the problem given to us? We are given a binary string s and an integer value k, and what they are expecting from us is we have to pick a subsequence out of the string such that the number that we are generating from that subsequence is less than or equal to k. And if this is true, then what is the longest or what is the length of that subsequence? We have to mention that. So in this case, I'll directly tell you the answer. The length will be something like this: 1, 1. These three items, if I pick 0, 0, 0, 1 and 0. If I pick these items, the length is 5. And the number that we are forming is 2, which is less than equal to 5. So this is something we have to return. And the length is 5. Length we have to return. And this was the problem statement. And here I am going to discuss over two approaches. Which one is first one is recursion. We can further optimize it using memorization. Second one is going greedy. That is very tricky. Okay, so first of all, let's just start thinking recursively. Let's say this is the string given to us and we have to check all the subsequences, and in the end I will see whether this subsequence is forming a number which is less than equal to 5 or not. If that is true, when I'm coming here and I am having a subsequence, I will just capture the length. If I am taking it, then I am left with this string and my number is 1. So what I have to do is pick couple of items from this string as well, append after this number, and see if it is less than equal to k. If I'm skipping it, I am left with this string and the number is 0. Now I have to start picking items from this index, but number I have chosen is 1. So this is the case where we have to pick an item or skip an item. See, this is a standard knapsack approach in DP category. So if you are not comfortable with this, try to explore a couple of examples over knapsack category, which is something like subset sum, house robber problem. Do practice those problems. Why I'm starting and going with the recursive approach? Because recursion is the main part for which these companies like Google, Amazon are going to evaluate your candidature. So applying skipping and taking style and left with this operation, this sub problem. So this is the P given to us and this is the sub problem. First sub problem, second sub problem. And again at this moment we have two options, either include it or exclude it. If I'm including it, then this number will become 10, which is 2 actually. This number I am keeping as an integer. So if it is an integer, if I do num less than left shift by 1, it is again 0. If it is something like this, number is equal to 1, and I'm doing left shift by 1, so it will become 2. Why? Binary representation is 1, and again the binary representation of 2 is 1 0, so it is like 1 left shift. So when I am applying this binary operator, left shifting operator on an integer number, I'm going to get integer, so I don't have to worry about converting the string, binary string, to the binary number and so on. Let me give another example. Let's say n is equal to 5, and if I have to do a left shift, what is the binary representation of 5? 4 plus 1. Left shift by 1, it will be 1 0 1 0. 8 plus 2, which is 10. So left shift of 5 is becoming 10. In this case, this 5 value is less than equal to k, but this value is not less than equal to k, so we cannot consider this left shifting, and we are going to close the call here. Okay, and so on, we can just keep on going ahead. So what is my problem? I'm just directly jumping to the problem so that keeping the video short. I'm starting with index I in my given string and keeping track of a number that I have formed so far, and I also need to keep track of the length. Initially it is 0, number is also 0, but if later on if I want to use DP, so in that case why not I just take some input and return some output so that I can cache these calls, and this integer will represent my length. Consider this as your problem. So starting with index 0 in the string, what is the maximum subsequence you can get such that the number represented by that subsequence is having value less than equal to k. K I am keeping global, as I am keeping global. So here in this case I just pick or do not pick over these values, and in the end I can decide if I is equal to s dot length. If I is equal to s dot length, now onwards I cannot make contribution to the length, that is return 0, right? When I'm picking an item, it is contributing 1 to the length. When I'm skipping, contributing 0 to the length. But if there is no item to pick, then definitely there is no contribution. So this will behave like a base case to me. And now I have to make decision on I. Integer, what is going to be my new number? Current number. Do the left shift by 1 and take OR with current character. What is the current character? As dot character at I, or maybe let's say directly writing character at I minus 0, so that if it is 0 character, it is 0 integer. If it is 1 character, 1 integer. So I just directly take the OR with this number. Let's say at this moment index I equal to 0, I have picked 1. At index 0 I want to pick 0, so number will be 1 left shift by 1, then I take OR with 0. Created new number. Now if this new number is less than equal to k, then I can take it. It means I can take the current character. Taking correct character means solution, whatever is the subproblem going to give me, plus 1. Taking current character and I plus 1, passing new number. And this is my possibility of taking it. And what about not taking it? Not taking it is just skipping it. Same number, same length, everything is same. So whatever is the minimum of t and take or not take, or take of skip, not minimum, I have to capture maximum. So whatever is going to give me the maximum length, that I can return. Maximum length, whatever is giving me maximum length, that I can return. So this is my knapsack style over it. At index I I can either take it or do not take it. So after taking it, I'm appending 1 to my length, and if I'm not taking it, I'm not appending anything to the length. And in the end, we can have the maximum length captured so far. So which is something like my initial call. And my initial call is solution starting with index 0 at string n with number n, whatever is the answer, that is my actual answer for string s. This is solution function. So this is my recursive approach. I just mentioned the recursion just to make you a bit revision on over the recursion part. Order of 2 to the power n. Why? Every moment, every index, I am making 2 calls, taking or skipping, taking or skipping. So 2 to the power n. But ultimately, this is my problem. Taking 2 variables, giving 1 output. So what are the different possibilities of these 2 variables? That is my number of calls I have to manage. It means what I can do is I can cache these calls. I underscore num. So this is the key. Against this key, if I just memorize it, it will go quadratic. But here, when you write the quadratic solution and try to submit it, you are going to get TLE because it's a very long string and they are expecting us to do something linear. So recursion with memorization approach is not going to work. I will give you the code and show you the code of this recursion with memorization approach in the coding section and at the end. Now let's try to move to the greedy approach. I come up to the greedy approach with the mindset that, see, I want a number which is a subsequence from this number that is less than equal to k. If I take all the zeros, 0, 0, 0, 0, the length is 4 and the number is 0 and 0 is definitely less than equal to k. So for sure we have to take all the zeros. So I have taken all the zeros and the length is captured so far is 4. Now I have taken all the zeros. I am only left with 1 that I have to take. Which one we have to take first? This is the least significant one. This one is going to increase the value of num by minimum amount. So whatever was the number 1 0 0 1 0 1 0, this was the number. And if I mark the indices 0 1 2 3 4 5 6, first of all I have captured all the zeros given the length is 4. Now I will try to pick one, and I will be picking one from the right side to left side. And this one, if I have to pick, my number is 0 initially, and that number, let's say it is n, and the length is 4, which is current count of 0. So I can keep it length or keep it count. So this is my current state. I hope you have understood so far. 4 is current length, number is 0, definitely 0. And value of k, if you just have a look, it is going till 1 to 10 to the power 9. So 0 is fine here. Now I will have to pick one from right to left. If I am picking this one, how much contribution this one is going to give to the n? This one is at which position? Let's see at which position. 0 1 2 3 4 5 6. This is 1. I have picked this one, and this one is at the second position from the right. But if you try to have a look, this is the index of this position from the right side, and we already know that these indices are something like this. If this is I index, then what is this value? This value is n minus 1 minus I. And the same by n minus 1 minus I factor, if I just left shift this 1, I have captured 1, and I just do the left shift by n minus 1 minus I. What will I get? I will get 1 0 and all 0 here. I will get the mask of this one. And mask of this one, if I just have to add this 1 to my number, I will have to take OR of n and this mask. So if I just take OR of these two, I will get this number added to my n. So after adding this, my new number is less than equal to k. Then this can behave like my new number, correct? Let me explain again. So this is very important actually. Initially 4 0 are there, 0 0 0 0. Then I'm picking this one. This one is something like this. 1 I am picked. I have to do the left shift so that it will become 0 1. Right? Then I will take OR. If I take OR, it will become 0 0 1 0. This is the number, and this number in the form of integer is 2, and 2 is also less than equal to k. So consider this value. It means this 1 can be added here. So the value will become 5, and the length will also be updated to 5. Now what about the second one? Let's move to the second one. Second one is this. Second one is at index 3, and I just take the mask. Mask will become like this. Now so far my number is this 0 0 0 1 0. 1, do the left shift by 3. 1 0 0. Take the OR and see if the number is 1 0 1 0 0, which is 8 2 10. 10 is less than equal to 5, but this statement is not true. This is wrong. So this one I cannot take. If this one I cannot take, I cannot take anyone. I cannot take any single one. Okay, so just discard this one, and yes, and last after this iteration is over, we can't do anything. So that is my approach. So if you just want to break down this approach, count all zeros, then from the right to left, whatever is my current number, take OR with 1 left shift by n minus 1 minus I, and new number should be updated to this one. And if new number is greater than less than equal to k, then this new number is my current number. And in the end, if I'm updating my new number, it means I'm taking 1 into my number, and also the length will be updated. Let me do the try of the same example. First of all, count all 0. So now my length is 4. Then go from right to left. Consider first one. If I am able to consider first one, then increment length by 1. Then try to consider is. If I can consider it, then consider it. If I cannot consider it, just break everything. No need to go further. And this is my answer. Now I will show you the code, and instead it is totally up to you whether you want to take two-step process, for loop for this, for loop for this. Otherwise you can take a single for loop where I is going from n minus 1 till greater than 0 and I minus. So this is my for loop, which is going from this position on the left side. And if character is equal to 0, then length plus, or you can say count of 0. Count plus. So count was initially 0. Count is 1 now. If it is 0, count plus. And what about the else part? In the else part, it means it is 1. If it is 1, let's see what is my new number. My new number is whatever is my current number. Take OR with 1 left shift n minus 1 minus I. This is something we discussed above. If you have not understood it, just try to watch it again. So if it is new number, if my new number is still less than equal to k, it means I can take this one as well. And taking this one means my number is equal to new number and count plus plus. Count is becoming 2. Right? And yeah, that's all we have to do. And here in the end, at the end, return count. Now you need to take care of one special case. Let's say my string is going till 1000 length and I am having 51. Right? 51. And my k value is also very large. So after considering these many ones, but my k value is definitely in the integer form. So when I'm doing the left shift here, when I'm doing the left shift, I'm doing left shift by n minus I minus 1. N minus 1 minus I, sorry. This is my position. So this position should be valid so that we are able to get a valid mask. If I'm shifting 1 by this value, it should be having a valid mask. So this value should be not less than 31. So this value should be less than 31. It should be a valid value so that I1 can be shifted at that position. So this is a special condition that you need to carry. Apart from that, it's pretty simple. And if you just go with the greedy, time complexity is definitely order of n, linear time. Now I will show you the code. Here is the recursive code that I have written, and this recursion code is going to give you order of 2 raised power n, because I just tried all the possibilities and I have not used memorization here. You can try with the memorization by considering collecting this I and num value as a key, and also need to make sure that you might have to take this num as long in this case. But recursion won't work here much because we are expected to do it in a linear time. For linear time we have to go greedy, and why we are deciding over greedy? Because 0 number is already less than equal to k, and 0 means picking up all the zeros from the string. I'm running a loop from starting to ending, taking the current character. If it is 0, then definitely it is going to contribute to the answer. If it is 1, it is going to contribute if the number is not crossing the limit. Why we are picking from right to left? Because on the right side we have least significant ones, on the right side we have more significant ones. So we definitely have to go from right to left. And this is the code. And why this position? See, we have limited space. This one less than 1 left shift position, this should also be valid. Let me run, and this problem will get submitted, and beating 100% of the Java solutions. And I hope you have understood this approach. This problem was a bit tricky, but it is very interesting and important from the interview perspective. So do let me know in case you have any doubt. Thanks for watching. Bye bye.